Hello everyone. In this video I am going to show you how to perform practical in big data analytics. But before that, let us discuss about concept of big data a little bit. Big data analytics. Big data is a state of art technology that everyone knows, like it is happening in the market and everybody is talking about big data and in data science. Okay, so you can say like with a broadening source of data pool, the topic is big data has received like increasing amount of attention in past few years. Beside dealing with gigabyte terabyte of data and spaces and shapes, it is also like decreased turnaround time of the analysis. Okay, so not only this speed and efficiency helped for immediate analysis of big data, but also identifying new opportunities. Okay, and this is in turn has lead to smarter business moves, more efficient operations, higher profit, and happier of the customer. So these are the benefits of the big data analytics. Okay, now so big data analytics we are going to perform using Apache Spark or other tools, but Apache Spark is very much famous. Okay, so what is Apache Spark? So Apache Spark was built to analyze big data with a faster speed. Okay, so one important feature that Apache Spark offers is ability to run computation in memory. In our online Zoom meeting, we discussed about the difference between Hadoop and Spark. So the best benefit of the Spark is the in-memory analysis that it provides. It also considered to be more efficient than MapReduce. Okay, Hadoop MapReduce for a complex application running on the disk. Okay, Spark is designed to be highly accessible, offering a simple APIs in Python, Java, Scala, SQL, and rich built-in libraries as well. It also integrates closely with other big data tools that we are going to discuss. And in particular, Spark can run Hadoop cluster and access any Hadoop data source, including Cassandra. Okay, so that is the benefit of the Spark. PySpark. So now what is PySpark? PySpark actually. So PySpark in this is the interface that gives access to Spark using Python programming language. PySpark is an API developed in Python for Spark programming and writing Spark application in Python style. Although underlying execution model is the same as like all other API languages. Okay, now it's time to perform practical tutorial. So before we go to perform practical tutorial, we need to check like which tool we are going to use to perform the practical. As I already told, like we are going to use a Spark, but these are the 2019 most famous or popular tool of big data analytics. Okay, so you can use any of the tools. Each tool is having their own advantage and disadvantage. Okay, but we are going to use the first one, which is the Apache Spark, and which specific tool is a PySpark we are going to use. So let's move to the practical. We are going to open our Google Colab to perform the practical. New Python 3. Let's give the name Big Data Analytics. Okay, now the question is, like in this tutorial we will mostly deal with the PySpark machine learning library MLlib that can be used to import any kind of model. Let's say we are going to use a linear regression model, or maybe other machine learning models we can also use, but linear regression we are familiar, so let's use the linear regression by using the PySpark library. Now the question is like, why Google Colab? Obviously Google Colab we are using since beginning. That is one of the reason like we are going to use Google Colab only. And another thing is like Google Colab is having their own set of features that supports with respect to Spark. We have discussed some of the benefits. Let us discuss one more time. Like Google Colab is a Jupyter notebook that we all knows, and it is powerful that leverages Google Docs features. Since it runs on the Google server, we don't need to install anything on our system locally. So that is the best benefit that I can say. Be it Spark and deep learning model, it's provide obviously. The most attractive feature of Google Colab, it is having a free GPU and TPU support. Okay, since GPU support runs on Google's own server, it is fact that faster some commercially available GPUs like NVIDIA, which is like 1050 Ti, and others also. And a piece of general information that I can share with you guys is like it has free RAM that you can use, GPU and TPU, that 11.6 GB. Okay, and the processing size is a 666.0 MB, and it has like GPU RAM is 11439 MB. Okay, so these are like features that you can even imagine that you are getting free in Google Colab. I have got an estimation from IT team about like if I need a GPU over here in our premises, they have given me a quote of single system was like $3,500, but here we are getting it free. So that is the best thing about the Google Colab that we can say. Okay, so that is what like that is the reason like we are going to use Google Colab. And we also need to see the big data analytics. So that is for that we are going to use a PySpark, Apache PySpark. Okay, so now to run Spark in Google Colab, first we need to install all the dependencies in Colab environment, such as Apache Spark, Hadoop, Java, find Spark, in order to locate the Spark in the system. The tools installation can be carried out inside Jupyter notebook of the Colab. So you don't need to go anywhere else and then do the installation. You can install over here only. Okay, so what you need to install? The first we are installing, that is the JDK, Java. Okay, so let's install Java by executing this command, apt-get install open JDK 8 JDK headless QQ. So this is for installing Java development kit. Okay, the another one that we are going to use is Apache Spark. Okay, so Apache Spark is having like their own different versions. Okay, here we are going to use version 2.4.4 and Hadoop 2.7. Okay, so let's get it from the Apache server first. Okay, so this command is to get access of Spark and Hadoop. It may take some time because the package is having large size and it may take more than 1 minute. It may take more than 2 minutes as well. Okay, so we go. It's done. Okay, so this is what we got the access of the file, and now the next command is why we are going to install. Okay, so first we got access of like Spark and Hadoop, and now we are going to install it, unzip and install it. Okay, so let's unzip. It's done. And the next last step is install find Spark to get access of the Spark within Google Colab. Okay, so here we have done with all kind of installation. Okay, so here all installation has done, Now the next step is like we are going to check whether installation is completed successfully or not. Okay, so now we have installed Spark and Java in Colab. It is time to set an environment path. Okay, we need to set an environment path that enables us to run PySpark in our Google Colab environment. So we need to set a location of Java and Spark by running some code. So the first one is import os, okay, os dot environment, no, not environment, just environ Java home. Okay, so this command we are executing, this code we are executing to set up path for Java, and os dot environ here spark underscore home. This command, this line of code we are executing running for locating the path of the Spark. Okay, but we need to give the path. Okay, so how we are giving the path? In double quotes we need to give the path. Okay, so where is Java? Now we need to check out Java because we already installed Java by executing this command, but we don't know where Java is located. So you need to go to the file and you need to go one step up. Over there you need to go to the user, and in user you need to go to the lib. In lib you need to go to JVM. Where is it? Yes, yeah, Java virtual machines, and over there there should be, because we installed that Java 8 OpenJDK AMD 64. Okay, we need to right click, copy path, and simply paste here. So this is what we have set the location of Java. Okay, now the same way we need to do with Spark. Okay, so where is a path, where is a file of Java is available? So we need to go to the content. Okay, because over there you can see this Spark files are available. Okay, so what you need to do, just content, and this is like zip file we are not going to use, but we just unzip by using this command tar. So we need to right click, copy path, and paste it here. So you see content Spark 2.4.4 bin Hadoop 2.7. So you have Spark 2.4.4 and you have Hadoop is 2.7. So these are the version. Okay, now let's execute this. Okay, executed. We just set the path. Now the next command. Okay, we can run local Spark session to test our installation. If you are getting error over here, that means there is some issues with the installation. If you are not getting error, then your installation is good. Okay, so what you need to do, you need to execute this command, import find spark .init from PySpark SQL, import Spark session, and then you need to execute this code. Okay, so let's execute this. Once again, if you are getting error in this line of code, then there is some issues with the installation, so you need to reinstall everything. But you see there is no error we are getting here, so that means we are good with the installation. Our Google Colab is ready to run PySpark. Now let's build simple linear regression. Okay, you can you can try to implement something else. Let's say, for example, random forest or a naive Bayes or support vector machine, other algorithms you can try. But as you are familiar with the linear regression, we are continuing with the linear regression over here by using this PySpark library. Okay, Once again, you know very well that linear regression model is one of the oldest model and widely used machine learning approach, which assumes a relationship between dependent and independent variable. For example, a moderator might want to predict the forecast of the rain based on the humidity ratio. Linear regression consists of a best fitting line through the scattered point on the graph, and the best fitting line is known as the regression line. Okay, so detail about linear regression we have already discussed in our previous chapters and study videos. Okay, so for our purpose, starting with a PySpark in Colab and keep these things simple, we are going to use a data which is a Boston housing data set. Okay, and the data which is available with me, you can find the information about data on this link. Yeah, the Boston housing data set. Okay, so you see there are 14 attributes of each case of the data sets, and these are the attributes. Okay, and why we are going to use, why we are using this data set? Because it's available freely. Okay, another reason is the goal of this exercise is to predict housing price from the given features. So we are having these features, and we need to predict price of Boston housing dataset considering MEDV. Okay, which MEDV? This one. Median value of owner occupied home in $1000s. Okay, so we are going to use this one MEDV feature, okay, as a target variable and all other variable as input features. Okay, you can download this data from the link. Here is a link. Yeah, here is a link where you can download the data, or I will also upload the data with a video, and you can use those data for sure. Okay, so that is one thing. Okay, now so let's upload the data, because I do have data already available in my system. So we need to upload the data by executing command that you know very well. There is some problem. Yeah, here we go. Sometimes session issues. Boston housing, you see 100% done, so data is uploaded. Okay, now you need to check whether data is uploaded or not. So go content, you see Boston housing CSV. Yeah, so you are in content and you can check like Boston housing .csv file is available, so we are good. So file is already available. Okay, and there is another way to check whether the file is available or not. Let's say ls is the command, the same Unix command that you can use. We are using ls command for listing files and directories in the Linux and Unix. So the same command you can use to check. You see there is a Boston housing.csv is available. Okay, so this command you can use. Now next, after we can see this file, what we need to do? For our linear regression model, we need to import vector assembler linear regression module from PySpark API, vector assembler, and that is like a transformer tool that assemble all features into one vector from multiple column that type double. Okay, so we should have used spring indexer if any of our column contains string values that we need to convert into the numeric value. But this data set, luckily, we do not have anything which is string. Okay, so we don't need to import a spring indexer. Okay, otherwise we need to use what? Okay, Once again, we need to use Spring indexer for convert data, Spring data into the numeric. But in our data set there is no, so we are not going to import it. Okay, so let's open the new cell and execute our code. These two different linear regression and vector assembler we are going to import to libraries packets and executing. Okay, there is no error. Okay, notice that we have used infer schema inside a read.csv file. Okay, infer schema, this infer schema, you can see why we are using this. The infer schema automatically infers different data types for each column. Okay, and let us print the data so we can see it very well. Okay, yeah, so here what we did, like, we print data set. So you can see the data is looking like, the same that we were checking on the website. You see, these are the columns that we are having information on the website. The same information is available over here. Okay, so you can see this is the data and it's uploaded, and we do have a schema also. So I think we are good. So you see there is no single attribute. It is having a string value. Fine. The next, so what is the next step? So the next step, that we will convert all features from different column into a single column, and we can call new vector column as attribute in out column. Okay, so that is the next task. Okay, so let's do that. Initializing one variable, that is assembler. So you see assembler, and we input all features in one vector column. Let me write it here. Input all the features in one vector column. Okay, yeah, so that is one thing. Apart from that, what we need to do, we need to define one output variable as well. Okay, so output assembler dot transform of the data set, and another one is a finalized data variable, that input versus output, and then we are going to show those data. Let's see. Yeah, so you can see the attributes and MEDV values. Okay, so these are the other attributes, and this is the MEDV attributes. Okay, here it is showing only 20 rows, but this is what the data that we are going to display. We are trying to work on. So you see attributes are input features from all the column, and MEDV is the target column. Okay, so this is the input features, and this is the targeted column. Now the next step, that we need to split training and testing data according to our data set. We can split into the 70-30, and we can also split into the 80-20. It is up to us. In this case, like, let's try to split data into, clear the output. Yeah, let's split into like 80-20. Okay, so by executing this code, we are splitting data into the 80-20, 0.8, 0.2. You can do 70-30 as well. It's up to you. The next is, like, we need to calculate the regression. Okay, so now we are going to calculate the regression model. So we are defining one variable regression is equal to linear regression, and the feature called attributes and MDV. Okay, so that is what you already check, that we are having attributes as the input features and MEDV as a target column. Okay, in addition we are also going to learn to fit model from training set. Okay, so that is also like, let's write here and we'll execute together. So this specific line of code is to learn to fit the model from training set. Okay, and the next is like predict the prices on the testing set. Okay, so let's write test data as well. Okay, so train data, test data, we have train data 80%, test data 20%. So here we are trying to predict prices on testing set of data, and with that what we can do is like predicting a model. Okay, print prediction dot show, that will show us output of attribute with the predictions. Here we go. So you see the predicted score is in the prediction column in the output. So this is the prediction of the, it will show obviously only 20 column. Okay, but yeah, we are getting predictions here. So now the next steps, let's print actually. We can also print coefficients, okay, of intercepts of the regression model by using coefficient command. Okay, so regression dot coefficients, that will execute and that will print coefficient. Okay, let's print intercept as well. Okay, so this command is this line of code is for intercept printing. So we have two variables and we need to print those two variables to get the values. Yeah, so here is the output. Okay, so once we are, you see, like we are getting this prediction values. Okay, dense vector values. So you see the coefficient values are this and the intercept values are this. Okay, is this one. Now once we are done with the basic linear regression operation, we can go a bit further and analyze our model statistically by importing regression evaluator module in the PySpark. So PySpark is having one module, that is a regression evaluator that you can use to evaluate your model. Okay, so let's import that specific module. So regression evaluator, that is the one what we are going to evaluate our model. So we are evaluating our model and transferring value into the eval variable. Here you can see evaluation regression evaluator label column, this one which is a targeted column, the prediction value and prediction value, and this is the metric name. Okay, and we can also calculate root mean. Let's check. Okay, we can also calculate root mean square error. Okay, so let's calculate root mean square error, which is, you are seeing here, RMSE. So this command is to check root mean square error. Okay, so we are storing root mean square error in RMSE command, and that has like predictions is the parameters that we are passing. We can also calculate mean square error. So this is for mean square error. We can also calculate mean absolute error. Let's calculate all the parameters, and we can also calculate coefficient of determination. So let's calculate that too. Okay, execute the command, you can see all four output. Root mean square error is 4.851. You can see mean square error is 23.531. Okay, you can also see like MAE, that is a mean absolute error, which is 3.363, and the last one is this coefficient of determination, okay, which is R2 0.781. That's it. So here we are done with creation of our first machine learning model using a PySpark in Google Colab. Okay, thanks for watching the video.